Automobiles have become indispensable to our daily lives. Cars powered by gasoline engines. Diesel-powered passenger cars and trucks. Compared to gasoline engines, diesel engines are finding a far greater range of applications. In agriculture, in construction, we will make a simple test. Atomized gasoline is taken into a cylinder which has a nickel chrome wire inside, and a ball is placed on top of the cylinder. Why does the ball jump off the cylinder? This is because atomized gasoline is ignited within the cylinder, forming combustion gases, which expand and force the ball out. This force is called combustion pressure. Utilizes fuel combustion pressure to operate pistons and obtain an output. This principle applies to both gasoline and diesel engines. In a gasoline engine, an air-fuel mixture is drawn into the cylinder and is compressed by the action of the piston. This air-fuel mixture is then ignited by a spark, and combustion pressure pushes the piston down. A spark plug is necessary to ignite the air-fuel mixture. Diesel engines do not require spark plugs for fuel combustion. In other words, the process of fuel combustion differs between gasoline engines and diesel engines. How can the fuel be ignited without a spark? Gasoline is used in a gasoline engine, while a diesel engine uses diesel fuel. Let us make a simple test to discover the individual characteristics of these two types of fuel. Gasoline easily catches fire when it is brought close to an open flame, but diesel fuel does not. This phenomenon is known as flash. In other words, gasoline is far more volatile than diesel fuel. Let us make another test and see what will happen when diesel fuel is dripped onto a plate heated by a gas burner. Diesel fuel ignites spontaneously when it touches the hot plate. This phenomenon is known as self-ignition. Then what will happen with gasoline? Gasoline does not ignite. Gasoline requires a higher temperature for spontaneous self-ignition, and this means that diesel fuel has a higher self-ignitability. And when this characteristic is utilized to the fullest extent, diesel fuel combustion can be achieved without a specific ignition system. Have you ever noticed that the valve nozzle gets hot when pumping air into a bicycle tire? Why is this? The temperature of air within a cylinder reaches 450 degrees centigrade when it is compressed to a ratio of 10 to 1, and the still higher temperature of 550 degrees centigrade is reached when the compression ratio is increased to 15 to 1. In other words, the higher the compression, the higher will be the air temperature. Diesel engines operate on this principle. Air alone is drawn into the cylinder and compressed to achieve a high temperature. Then fuel is injected into this air. Contact with high temperature air ignites it, and the resulting expansion of the combustion gases exerts a pressure on the piston head. Compression self-ignition, the principle on which the diesel engine operates. Now let us see what happens in a diesel engine. Air filtered through the air cleaner is drawn into the cylinders and compressed. The fuel is pumped from the fuel tank by the feed pump and is taken into the fuel filter. Filtered fuel is then fed into the fuel injection pump, where it is pressurized by plunger before delivery into the injection nozzles. Pressurized fuel is injected into combustion chambers and ignited in contact with the high temperature air. Now let us look at the individual fuel system components. To achieve complete fuel combustion, it is necessary to inject fuel into the combustion chambers in the form of fine particles, and this is accomplished by the injection nozzle. For efficient spraying, high pressure is needed. The injection pump is adapted to deliver the fuel under pressure. Fuel is pumped into the fuel filter by the feed pump. The fuel filter is designed to remove dust, water, etc., things that harm a diesel engine. Fuel reaching the injection pump is pressurized before it is injected via the injection nozzles. The feed pump, the fuel filter, the injection pump, and the injection nozzles are the important parts of the diesel engine fuel system. Motor vehicles are used under varying operating conditions, and volume of fuel delivery, injection timing, etc., must be controlled to meet engine requirements. The governor is a device which controls the volume of fuel injection in correspondence with the amount of foot pressure applied to the accelerator pedal, and the timer controls fuel injection timing. Shown here are the governor and the timer with a part cut away to show the internal mechanism. This is the governor. This is the timer. When a vehicle is climbing a slope and greater engine torque is required, the governor works as illustrated, allowing the fuel injection volume to increase. In a diesel engine, a metered volume of fuel is injected into the compressed air in the combustion chamber to effect complete fuel combustion, so that the amount of carbon monoxide and hydrocarbon in the exhaust gases is relatively small. These are the principles and characteristics of diesel engines. Let us now turn to the combustion chambers, which are important for obtaining efficient fuel combustion. Diesel engine combustion chambers can be classified into the following three general groups: direct injection type, pre-combustion chamber type, swirl chamber type. The direct injection diesel engine features excellent thermal efficiency and fuel economy, as the metered volume of fuel is injected directly into the combustion chamber in the piston head. In a pre-combustion chamber diesel engine, the fuel is combusted within the pre-combustion chamber before it is taken into the main combustion chamber. This type of diesel engine features smooth and quiet fuel combustion. The swirl chamber diesel engine is similar to the pre-combustion chamber diesel engine in design, but has a relatively larger chamber in which air is swirled and compressed, and fuel is injected directly into the swirl. This type of engine has a high combustion velocity and is suited to high-speed operation. While driving, care should be taken not to cause engine overrunning. The term overrunning refers to a condition in which the engine is run at a speed beyond maximum allowable speed. To avoid overrunning and the resulting damage to vital engine components, control your speed, particularly when coasting with the engine brake on. On some models, a label showing maximum allowable speed in each gear is installed in the driver's compartment, and its recommendations should be followed closely. Run out of fuel? When the engine stalls due to lack of fuel, it cannot be restarted by merely filling the tank, because air is drawn into the fuel circuit. To remove air, bleed the circuit by operating the feed pump manually. Since the diesel engine incorporates a fuel injection pump consisting of precision-finished parts to which dust and water are detrimental, it is important to have the fuel filter serviced regularly. It is also important to use high-quality engine oils specified for diesel engines. "80 years have passed since the diesel engine was invented by Rudolf Diesel in pursuit of higher thermal efficiency. Research and development have continued to create lighter weight, more compact, higher speed, higher output, lower noise, and lower fuel consumption diesel engines. And the time has come to take a new look at the broad range of use possibilities for the diesel engine. Compact yet high-speed and high-output diesel engines are now being used not only for heavy-duty vehicles, but also for light-duty trucks and passenger cars. We feel that diesel engines will find a wider range of application in an ever larger variety of fields, contributing further to the conservation of our limited natural resources and to the anti-pollution movement.